All right, so this is question 8. Let us quickly begin to solve. So in case you have any questions or you want to contact me, you can use any of these lines on the screen. You can just pick any of them, then text it either on WhatsApp, YouTube, Telegram, Twitter, Instagram. Then I'll respond to you as quickly as I can, or as soon as I see your text. All right, so if you want to find out more about tuitions or you want to know how I conduct these lessons, you can simply use those same lines. Or if you have a question, you can simply contact on those same lines. All right, so let's quickly begin to solve the question. So this question is asking us to find all the solutions of the equations in this given interval, which is from 0 to 360 degrees. So this is a very simple question. If you understood how we answered, the first question, which was question 7, this is going to be a very simple question for you. Okay, so let us quickly begin. So the first question here is we have 3, then we have cos 3x is equal to 1. So we will first start by dividing everything by 3 so that we can just remain with cos x this side, cos 3x this side. And then we say this is equal to 1 over 3. Oh, this is 1 over 2 rather. So there's a 2 here, not a 3. Okay. So we have 1 over 2 this side. Okay, so the other thing is we have to find the reference angle. So how do we find the reference angle? First of all, let us look at the angle that we've been given here. If it's a multiple angle, then we have to equate this to a certain parameter, which we are going to call y. You can just pick any variable from the alphabet or any Greek symbol or any symbol. So myself, I like using phi, so I can say let cos, or let me put it this way. Let 3x be equal to what? Phi. Meaning, while there is 3x in this equation, I'm going to put what? Phi. So I'm going to have something like this. Cos phi is equal to 1 over 2. Hence, to find the reference angle, which is phi, we're going to find the cos inverse of 1 over 2. So cos inverse of 1 over 2 is simply just 60 degrees. So this is not the final answer. This is just the reference angle. So we're going to use the reference angle to find the answers. So how do we use this angle to find the answers? So we need to check the symbol that we have in front of this number that we're going to have this side after dividing by 2. So after dividing by 2, we got half, and this is positive half. This is not a negative. So you have to check whether it's a positive or a negative. So since it's positive, we're going to consider that this trigonometrical equation is positive. So where we have to check the quadrants where cosine is positive. So when we look at the quadrants, these are the quadrants. We have in the first quadrant, all the trig ratios are positive. In the second quadrant, only sine is positive. So we have the first quadrant, then we have the second quadrant, and we have the third quadrant, and we have the fourth quadrant. So in the first quadrant, all trig ratios are positive. The second quadrant, only sine theta is positive. In the third quadrant, it's only tan, which is positive. And then in the fourth quadrant, it's only cos, which is positive. So we have to check where cos is positive. So we know to say in the first quadrant, all trig ratios are positive, meaning even cos here is going to be positive. And in the fourth quadrant, cos is positive. Hence, we can conclude by saying, therefore, therefore this angle lies where? It lies in the first and the fourth quadrant. In the first and the fourth quadrant. So in the first quadrant, we have to find what this angle is in the first quadrant. So in the first quadrant, you simply just get the same reference angle. You say phi is equal to 60 degrees. But remember, phi was equated to 3x. So meaning while there's phi there, I can put 3x and this will be equal to 60. So my x will therefore be equal to, when I divide by 3 this side, divide by 3 this side, I'm going to get my x to be 20 degrees. So this is the first answer. So let us find the second answer. So how do we find the second answer? We can get the other quadrant where cos is positive, and we said it's the fourth quadrant. So in the fourth quadrant, we know to say, if you are taking the second quadrant, we always say 180 degrees minus the reference angle. If you're taking the third quadrant, we say 180 degrees plus the reference angle. And then if you're taking the fourth quadrant, we say 360 degrees minus the reference angle. So in this case, we're taking cos, which is in the fourth quadrant. Hence, we're going to say 360 minus phi. So we're going to say in the fourth quadrant. So in the fourth quadrant, we're going to say phi is equal to 360 degrees minus the reference angle. Or you can name this angle to be, okay, let me just use phi. So this one is just the reference angle. So we say 360 minus the reference angle, which is 60 degrees in this case. So when you do the subtraction there, you're getting your phi to be equal to 300 degrees. So after doing that, you can replace back your phi, which is 3x here. We said phi is equal to 3x. So we say 3x is equal to 300 degrees. So we divide by 3 to find x, which is just 100 degrees. Therefore, the values of x are simply 20 degrees and 100 degrees. So do we have any questions before I can proceed here? Okay, so we move on to the next question. So the next question is this one. The next question is this one. So I'll be a bit fast so that we can cover as many questions as possible, because I'll start teaching the second years at 2030. Okay, so let's quickly move on. All right, so part B, which is 2 sine squared x minus sine x minus 1 is equal to 0. And then we've been asked to find, the value, or all the solutions for this equation. So remember what I told you, the easiest way to solve such an equation, you simply just equate, because when you look at this equation, it's in the format of a quadratic equation. So I'm going to say, let sine x be equal to any variable. Let's say I'm going to use y. So meaning while there's sine x, I'm going to put y. So this will simply just be equal to 2y squared minus y minus 1. So this one, I've done this in order to just make my work easy, because I know that if I'm using sine to factorize, I want to write a lot of things and hence waste a lot of time in just writing. So I've just made my work easier. If you want, you can use sine like this, the way it is, and solve it step by step. But this one is a bit simpler. Yeah, so it's a bit simple to use a variable. So let us solve this quadratic equation. So the product of this quadratic equation, we multiply 2 and -1, we're getting -2. And then the sum is simply just -1. And then the factors of this quadratic equation, two numbers that we can multiply to get -2. And when we add them, we should get -1. So these numbers are simply just 1. Yeah, 1 and what? So these numbers are simply just 1. Let me just write it properly. Okay, so 1 and -2. When you add these two numbers, you're getting -1. When you multiply them, you're getting -2. So we can plug them into the quadratic equation. So we have 2y squared plus y minus 2y, then minus y is equal to 0. So we say y open brackets. So we have 2y, then plus 1, then -1 is common. We have 2y plus 1 is equal to 0. So we're going to have 2y plus 1 and y minus 1 is equal to 0. So the first part here is 2y plus 1. So we're going to equate it to 0. So equate 2y plus 1 to 0. Then we also equate the second part, which is y minus 1 to 0. Then when you do that, you discover that the first equation that you're going to have will result to 2y is equal to -1. So y will be equal to -1/2. And then the second equation that you're going to get will be y is equal to +1. So now, remember, we equated y to what? To sine x. So meaning while there is y there, I'm going to put sine x. So this will be sine x is equal to -1/2. Even this side, we say sine x is equal to 1. And then the other thing that we're supposed to do here is we find the reference angles now. So let me start first by solving this equation, and then I'll come to this one later on. So let us keep this equation. So here we expect to have 4 answers. So the first one, we find the reference angle for this first equation here. So how do we find the reference angle? First, we're going to consider sine x. So I'm going to say sine phi. Sine phi should be equal to what? The positive of this angle. So I'm using positive. I'm using phi because I've changed the sign here. It was negative, I've changed it to positive. And this is just for the sake of finding the reference angle. And then when you're finding quadrants, that's when we're going to consider this negative here. So let us find the value of this reference angle, which is phi. So phi will now be equal to sine inverse of what? Of half. So sine inverse of half is simply just 30 degrees. In case you are wondering where I'm getting these numbers, the special angles, the solutions of these special angles, you can just you should just tell me immediately after the lessons. I can send you the video where I explained the best way to master these special angles. It's very simple. Once you just watch that video, it will be easier for you to know them. Even in the exam, you don't need to master them. You know how to come up with a table that has all these values. Yeah, so we found the reference angle to be 30 degrees, but this is not the final answer. This is just the reference angle. So now, where is sine negative? Remember, we said we're going to consider this negative the time we start looking at the quadrants. So we know that the quadrants are like this. In the first quadrant, all trig ratios are positive. In the second quadrant, only sine is positive. In the third, only tan. And then in the fourth, only cos is positive. If you want to master this, you simply just say, in the first quadrant, starting from the first quadrant, you simply just say, all students take coffee, or all students take calculus. Or if you want, you can start from this side, go in this side, and then just say acts. ACTS, if you don't want to forget. Yeah, so we have to check where sine theta is negative. So in which quadrant is sine theta negative? So sine theta is positive in the second quadrant and in the first quadrant, meaning it will be negative in the third and fourth quadrant. So in the third quadrant, if you remember very well, I said in the third quadrant, we consider the angle to be 180 degrees plus the reference angle. So in the third quadrant, so we say in the third quadrant, our x our x will just be equal to 180 degrees plus the reference angle, which is 30 degrees. So the value of x becomes 210 degrees. And then in the fourth quadrant, we have the value of x being equal to, in the fourth quadrant, if you remember, I said 360 minus the reference angle. So we say 360 degrees minus the reference angle, which is 30, and this gives us what? 330 degrees. Okay, so we have found two angles, and the most important thing again is what you've been given here. You have to make sure you check if whether the angles, the final answers that you have found are all in this interval that you have been given. So when you check 210, 210 is between 0 and 360, meaning it qualifies to be one of our answers. Even 330, 330 is between 0 and 360, meaning it also qualifies to be one of our answers. So let us also solve this one. So we find, so for this one, we also have to find the reference angle. So how do we do it? We find sine inverse of 1. So sine inverse of 1. So sine inverse of 1 is simply just 90 degrees. So in which quadrant is, in which quadrant is sine theta positive? Because when you check the front part of this number here, there's a positive. So in which quadrant is sine theta positive? So sine theta is positive in the first and in the second quadrant. This is what we said here. So sine theta is only positive in the first and the second quadrant. And we said in the second quadrant, you always write 180 minus the reference angle. So in the first quadrant, you always get the same reference angle as the answer, this same reference angle. So in the first quadrant, we say the value of x is simply just equal to what? 90 degrees. And then in the second quadrant, x will therefore be equal to 180 degrees minus 90 degrees, which still gives us what? 90 degrees. Hence, the solutions for x are, you list them starting with the smallest number, and you list the repeating numbers once. So the values of x are simply just 90 degrees, and you make sure that all the numbers that you list here are in this interval that you have been given. So we have 90 degrees, and then we have 210 degrees, then you also have 330 degrees. So these are the answers for this equation here. I hope everything is clear. Do we have questions before we can proceed? Okay, so let's quickly move on. So move on to the next question. So I'm going to make sure that I solve all the questions here so that you don't remain with questions. But if there's any question which is similar to the other, I'll leave it as an exercise. So let's take a look at this one here. So this one is also simple. We have two sine x tan x minus tan x. And then when this one crosses the equal sign, it will be, okay, let me just leave it this side. Let me change this one. I'll take this negative 2 sine x to the other side of the equal sign, meaning it will be 2 sine x. Then we say this is equal to 1. And then from this equation, you can see there are things that are common, which you can put together. So let's try to do that. So there are many ways in which we can solve this equation. Okay, so we can simply just say, okay, so we can simply just factorize here. So when you factorize tan x here, we'll have tan x outside. Then in the brackets there, you simply just have, you have 2 sine x minus 1. Okay, and then from there, okay, I've seen something very important here. So let me not take this, let me not bring this to this side. Let me just leave it the way it was. So whenever you're solving trigonometry, you have to be putting in mind all the trig identities. You need to know them. They need to be on your fingertips. So we have minus tan x. Then this one, let me just leave it the way it is. 1 minus 2 sine x. So when we factorize tan this side, we're going to have, when we factorize tan x, we're going to have 2 sine x in brackets and then minus 1. Then this will be equal to 1 minus 2 sine x. So what we can do is we can divide everything by 2 sine x minus 1, 2 sine x minus 1. And then when you do that, this side will just remain with tan x. And then on the other side here, we're going to have 1 minus 2 sine x. Then everything divided by 2 sine x minus 1. So now I want to cancel this on top and this down. But when you check, they are not the same. But how do I cancel them? Or how do I make them the same? Because they are containing the same terms. We have 1 there, we have 1 there, we have 2 sine x, we also have 2 sine x. So meaning in some way, after simplifying these two expressions, at some point they can cancel. But how do we do that? So to do that, we can simply just factor out the negative. You can factorize the negative out of this equation on top. So we're going to have something like this. When you factorize the negative from the numerator there, you get a negative outside there. And then in brackets, you have negative 1 plus 2 sine x. And then everything over 2 sine x minus 1. So when you check these two equations, they are the same now. How am I saying they are the same? Or if you check this one here, it's just the same as that one. Because when you multiply this negative times negative 1 in brackets there, you get positive 1. Negative times positive 2 there, you get negative 2 there, which takes you back to the same equation. So this is simple now. It's easier now to solve. So how do we make sure that what we have found here is cancelling with, what we have found on top is cancelling with the denominator? We can simply reassemble what is on top there. So we have 2 sine x, and then we write this negative 1 in brackets. And of course, we have a minus outside this side. And then down there, we still have 2 sine x, then minus 1. So you can see that this can now cancel with that. So this now makes our equation simple. So our equation will just remain as tan x is equal to, so we've only remained with a negative there, so which is just a negative 1. If you want, you can just put negative 1, then negative 1 there. It's just the same as putting negative. Yeah, so we're just remaining with negative 1 because this into that is 1. Okay, so here is now easier. We can now find the reference angle. So how do we do that? So I'm going to say let tan phi be equal to positive 1. So let me find the reference angle, which is phi is equal to tan inverse of 1. And the other thing we have to do from here is to find the tan inverse of 1. So tan inverse of 1 is simply just 45. So our reference angle is simply just 45 degrees. So we have to check the quadrants again. So the quadrants, we know that in the first quadrant, all trig ratios are positive. In the second, only sine is positive. In the third, only tan is positive. In the fourth, only cos is positive. So now, where is tan theta negative? Because we have negative 1 this side. So tan is positive in the first quadrant and in the third quadrant, meaning it's going to be negative in the second and in the fourth quadrant. So this is how we're going to do it. So we know to say tan is negative in the second and in the fourth quadrant. So in the second quadrant, so we can say in the second quadrant, so these numbers I'm writing in short forms, I mean letters I'm writing in short forms, you have to finish them when you're writing with your pen. So you say in the second quadrant, you say in the second quadrant, the value of x is simply just equal to what? Remember, in the second quadrant, we said it's 180 minus the reference angle. So this would be 180 degrees minus 45 degrees. And this gives us what? 135 degrees. It gives us 135 degrees. And then we also move on to the fourth quadrant, because we said in the fourth quadrant, tan is also negative there. So in the fourth quadrant, we said to find the value of the angle there, you say 360 degrees minus the reference angle, which is in this case 45 degrees. And this gives us what? This should be 315 degrees, 315 degrees. So it's as simple as that. So the angles, therefore, the values of x are simply, the first one is 135 degrees, then the second one is 315 degrees. So these are the two values of x that they wanted us to find. And you have to check that these values are all in the interval that we've been given, which is this one. All right, so let's quickly do this one. I think this one, I'm not going to finish it for some reason. It's almost the same as this one. I'm not going to finish it. I'll leave it hanging so that we can also have time to do these others. All right, so let us do this one. Let me just show you how to solve this one. So we have the root of 3 sine 2x is equal to cos 2x. So this one is simple and straightforward. We can divide everything by, let me start first by dividing by cos. So if I divide by cos 2x, I'm going to have the root of 3. Remember when I was explaining trigonometric identities, I said sine x over cos x is simply just equal to what? Tan x. So meaning sine x over cos x, I mean sine 2x over cos 2x is simply just equal to what? Tan 2x. And this is just going to be equal to this, and that will give us a 1. Then we have to divide everything by the root of 3, so that we can remain with tan 2x this side is equal to 1 over the root of 3. So this one is similar. The way you solve this equation from this point is just the same as the way I solved this one. So the first thing is that you equate this angle there to phi. So you say let phi be equal to 2x. And from there, you're going to have tan phi is equal to 1 over the root of 3. And then from there, you can find the reference angle, which is tan inverse of 1 over the root of 3. And this will simply just give you what? 30 degrees. Yeah, so this will give you 30 degrees. Then from there, you can find the quadrants in which tan is what? Is positive. Yeah, so you can find the quadrants in which tan is positive. And from the quadrants there, we know that tan is only positive in the what? In the third quadrant and the first quadrant. So in the first quadrant, the value of phi will be equal to what? The value of phi will be equal to 30 degrees. I said in the first quadrant, you just get the reference angle as your answer. So 30 degrees is the answer, but remember phi is equal to 2x. So we put 2x there is equal to 30, and then we divide by 2, the value of x becomes 15 degrees. In the third quadrant, we said this should be 180 degrees plus 180 degrees plus the reference angle that we've been given is what? Is a 30, the one that we found. So we said this should be equal to what? Phi. So when you add that, you're getting 210 degrees is equal to 5. So the value of phi is 2x. So we put 2x there. So we say 210 degrees is equal to 2x. When you divide by 2, the value of x becomes what? Is it 105 degrees? Yeah, so these are the two answers for x. I've then ended up finishing up the question. Anyway, let's see the other questions. So we have this one. So I'm just going to be solving them fast because they are simple. So for this one is also straightforward. We have 7 sine 2x plus 30 degrees, and then we say this is equal to 3 cos 2x plus 30 degrees. So this one is also simple. We can simply just divide by cos 2x plus 30 degrees, and then we'll also do the same this side, 2x plus 30 degrees. So this and that will give us 1. This part, sine over cos, gives us what? Tan. So sine over cos will give us tan. And then this will be 2x plus 30 degrees. Then we say this is equal to 3. So we can divide by 7, divide by 7. The value of tan, so this will be 2x plus 30 degrees is equal to 3 over 7. And this angle is not in the group of special solutions. Yeah, so even if you find tan inverse of this, if you don't have a calculator, it's difficult to find the answer. As a result, we can simply say this is, we can simply just, anyway, if you are clever enough, you can't end here, but if you don't have calculators in the exam, if you're not allowed to use calculators, you can simply just leave it here, or you can go further by saying let phi be equal to what? 2x plus 30 degrees. So when you do that, then you're going to have tan phi is equal to what? 3 over 7. So that you have your reference angle being equal to tan inverse of what? 3 over 7. So if this is your reference angle, you can check. Here we have a positive, and hence the value of, we have to find the quadrants in which tan is positive. So tan is positive in the third and in the first quadrant. So in the first quadrant, the value of, the value of phi is simply just equal to the reference angle. Hence, this will be equal to, the value of phi is equal to the reference angle. The reference angle in this case is simply just what you have there, which is just tan inverse of 3 over 7. And therefore, the value of phi, we said it's equal to what? 2x plus 30. So we say 2x plus 30 is equal to tan inverse of what? 3 over 7. And then to find the value of x, you just make x the subject of the formula in this case. So meaning this will be tan inverse of 3 over 7. And then you say minus 30, everything divided by 2. So this is your first solution. And then your second solution is also found in a similar way. But of course, remember, in the third quadrant, we always say, to find phi, we say, in the third quadrant, we say 180 degrees plus the reference angle, which is tan inverse of 3 over 7. So we put our phi this side, which is 2x plus 30 is equal to 180 degrees plus tan inverse of 3 over 7. And when you make x the subject of a formula, you get the simplified solution as x is equal to 150 degrees plus tan inverse of 3 over 7, everything divided by 2. These are the two solutions that you are required to find. Do you have any questions? Do you have any questions before we can look at the last part? Okay, so the last part is also simple. The last part is also simple. let us do the last part. So this one, in the remaining 1 hour 30 seconds, I think I can just show you how to solve it. Yeah, so this one is simple and straightforward. So you know that when you divide everything by sine 2x, you are going to get 5 tan 2x on the left. Then this will be, oh, we have a 1 here. Yeah, okay, this will be plus 1 over sine 2x. I didn't see that there is a 1 there. Okay, so okay, let's see how we're going to do this. Okay, from there, we are going to have tan 2x this side. Yeah, but I think this is a simple question because when you take this to this tan to the other side of the equal sign, you're going to have 5 tan 2x minus that. You're getting 4 tan 2x. And when the time is even up, but this question is simple. You just need to simplify it, and then after simplifying it, you find the solutions. Okay, I'm giving this question as an exercise. You can solve it and then send it after finding the solutions. Then I'll check if you are correct or wrong. And then you should join using the same link when this link finishes. When this link ends, join using the same link so that we can proceed. Yeah, can do other questions.